This is video 3.1.1, and the goal of this video is to understand the exponential functions. So the good news is you've seen this before, so we're going to be reviewing what you've seen before and talking about how everything you've learned this year can help you make sense of more functions, and in general we can talk about the transformations of different functions. So the Challenger is an example of an exponential function. When the Challenger exploded, there's a function that describes, it's exploded because of the failed number of O-rings, which is described here. This function down here describes how many O-rings will fail at a certain temperature, and this will grow exponentially as the temperature changes. So the worse the temperature, the more failed O-rings will occur. And it will grow not just linearly or in a quadratic form, but exponentially, which is much faster than any of the other forms. So we're going to be taking a look at that as an example to kind of make sense of this. So a couple of reminders about what is an exponential function. Exponential functions are the form b to the x, where b is some number. And you see three examples here of an exponential function. And you see three non-examples. So a couple of things. B cannot be 1, okay, cannot be 1, and it cannot be negative 1, or in fact any negative number. It can get into the fractions, notice, so it can be less than 1, but the minute it hits 0 and below, it is no longer an exponential. So that's a couple of restrictions on B. B has to be greater than 0, and B cannot equal 1. And it should be obvious why that's true, because 1 to any power is just 1. So why do we even have that in our function? Okay? The negative doesn't work because we know that when we take a negative to different powers, we get a negative answer sometimes and a positive answer at other points. So it won't have the same characteristics as these exponential functions that we will look at, where the following is true. Okay? And this is just the parent function. And if we were to look at transformations, we're going to start to see a slightly different function. So we're going to kind of take a general look at things in this video. In the next video, we'll look a little bit more in depth. So let's see how to evaluate exponential functions. So again, the morning the Challenger was launched, the temperature was 31 degrees colder than any previous experience. Find the number of O-rings expected to fail at this temperature. So it's as simple as plugging into our calculator, 13.49 times 0.967 to the 31st power, and then minus 1. So we're going to enter this into our calculator and find out what the value for the function is. And so of course, remember that caret symbol means take it to the power 31 that you use on your calculator, and then we get about 3.8. So the answer, we would say almost 4. Almost 4 of the O-rings would be expected to fail, and probably 4 would be expected to fail at this temperature. Simple as that. So with that, that's a simple application of exponential functions, but let's talk about how we graph them. Okay, so here's a variety of graphs. Notice that, pretend the A's are B's. So in this picture here, all these A's really represent the B value here. So this line right here is f of x equals 3 to the x power. Notice a few things. We have a lot of similarities between all 6 of these lines. We see an asymptote occurring at the x-axis. They are all getting exceedingly close to the x-axis. So think about why that is. What happens as x gets increasingly negative? So what happens as, for instance, if we look at the original one that I talked about, if we put 3 to the negative 20th power, what does that mean? Remember that a negative exponent really means 1 over 3 to the 20th. 3 to the 20th is huge. That's a big number. And 1 divided by a big number, or 1 divided by infinity, remember, gets really close to 0. And it will never equal 0 because we'll never be able to plug in that massive number, but we will get exceedingly close to 0. It will approach 0 as we get large. But what about the lines going in the opposite direction, like this blue line? This blue line also gets exceedingly close, but it's when x's are exceedingly large. Think again, if we take 1/2 to the third power, so we're looking at this point here on the blue graph, we take 1/2 to the third, remember that just means 1/2 to the third. And that will equal 1/8, which is a very small number. So as we get exceedingly large with this one, we'll get to 0. But remember, if we do 1/2 to the negative third, so now I'm talking about this point way up here, that really means I'm going to take 1/2, I'm going to take the reciprocal of it to the third power. So really that means 2 to the third power. So remember, your exponents are taking the reciprocal of the number to the third power, okay? And this will be 8. So I guess I didn't find that point very accurately, but it's going to be this point right here at 8. So those are some reminders about exponents and how to take those powers. But here's some things we can summarize. Both of them will approach 0, but when b is a fraction, so when b is between 0 and 1, then it's going to be this downward facing exponential function. Those are all those fractional ones. When b is anywhere greater than 1, it's going to be an increasing function. So that's one of the first things that we'll decide. And of course, both of these will approach 0 at some point in the function. The next thing that we want to notice is that they all have this point in common. Why do they all equal 1 right there? What is it about x equaling 0? Why is b to the 0 always appearing to be 1? So remember, any number to the 0 power equals 1. Another simple point that you'll always find when graphing. So you'll think about when is the power 0, and that will make it 1 at that value. So that'll be a simple point that we'll always graph when we're looking at these functions. So let's take a look at 3 examples that will be similar to your checkpoints. If we're looking at f of x equals 3 to the x plus 1, remember you can always go back to a table or using your calculator to graph these functions, but let's think about transformations. Notice that whenever we altered the x value, that shifts our value left and right. Let's think about why. If we were to make a table, let's think about where we would get the value of 1 on our graph, because that was a key point in that previous graph. I would get the value of 1 when this is 0. And that becomes 0 at negative 1. So if x is negative 1, f of x would be 1. So that's a point I can quickly graph. Negative 1, 1. Again, think if my exponents was negative, it's going to go closer to 0. So my graph is going to get closer and closer to 0. I'm also going to plug in a couple of more points, 0 and 1. 0 and 1 for x, not for y. If I plug in 0, I get 3. And if I plug in 1, I get 9. So my graph at 0 is 3. My graph at 1 is 9. And I have my exponential function. So this key point of when we get the value of 1 for the function is always going to depend on a shift. And sometimes we'll have a vertical shift. So again, this next one, it actually took the parent function b of x and it shifted it down 3. So we've seen these transformations. We took the parent function 2 to the x. So if I were to graph 2 to the x, remember it would be at 0 right here. At the first power it would be 2, and 2 to the second power would be 4. This would be the parent function, 2 to the x. But now I'm going to take that and I'm going to shift it down 3. Because every time I plug in for x, I'm going to go down 3. So I'm going to go down 1, 2, 3. So this graph no longer has an asymptote at 0 because it's been shifted, but it has an asymptote at -3. So I would want to sketch that in to show that that asymptote occurs at -3. Okay. Once again, you can always just make a table. If I plug in 0, I will get -2. So if I plug in 0 for this one, and I make a table, at 0, I would get -2, because at 0, this would be 1 minus 3, -2. At 1, I would get 2 here, minus 3, -1. Again, 1, -1. And then at 2, I would get 2 to the second, which is 4, minus 3, which is 1. So I should have actually gotten right into that point right there at 2. But transformations are your friends here to help you see where this graph would fall. This next one looks like it has multiple things going on. It has a shift to the left 1. So that means I would take this original parent function, 2 to the x, and I would shift it to the left. I'm sorry, to the right 1, excuse me, because when we shift in the x power, we're going to go the opposite direction. But then also it has what we would call a flip. This negative will flip the graph upside down. So this graph will be flipped down. And sadly, this graph always does this to me. So originally it was going to be here, and it will be flipped. So let's see. Okay, here's where it would land if we flipped it down. Okay, so if I were to undo that so you could see it, it was originally here. If I flip it down, it's still going to be on this point right here, but it would be going downwards. So it would flip down to here. This one would flip down below and be down 4 from that point, and so on. It will flip down. A couple of key points we could plug in again. We can still plug in our key points like 1 for x, because that makes the exponent 0, and we would get -1. And if I plugged in the number 2, I'd get negative, and then I'd have 2 minus 1, which would make it a power of 1. It would give me an answer of -2. So this flip would actually be around the x-axis. And if I plug in 3, I would get the second power, which would be -4. A couple of things with this negative. We're going to talk more about this negative in class. It won't be in your checkpoints. But this negative does not say take -2 to the power x minus 1. It says put negative on the 2 to the power x minus 1. This is very different. You have to do exponents before you flip the value. Okay, so exponents first here. So first we take 2 to the power, and then we put the negative on it. So this value would give me -4. So my graph would become, so at 2 and 3, it would be -4. So my graph would be at, instead of being here, we saw this graph going here. It's going to be below. So it's going to be at -1, -2, and -4. It's still going to have an asymptote here at 0. It's going to grow exponentially down like that. So my graph will get flipped down. So remember, these graphs here basically would mirror image it down below the x-axis if we were doing putting a negative out in front of that b. So we'll talk more about the negatives in class and do another example together and kind of talk about what you remember from last year. Here are some problems that I'd like you to try. So start with graphing 4 to the x, and then see if you can graph the 2 transformations of that. Okay? So think about how that would transform it, or make a table and think about what happened to these different graphs. So graph these all three on the same piece of graph paper. Bring them into class and kind of go over this and review what you did last year with Algebra 2.